Hey, this is Rick from TypeScriptGames.com and putting together another TypeScript game dev tutorial. In this one, we're going to take what we had already built from the previous tutorial where I taught you how to draw to the canvas just using some of the basic draw commands. And we're going to be adding first some keyboard input so that you could, use the up, down, left, right arrow keys and the space bar to add to your game. Then we're going to do a little bit of rotation and acceleration on the spaceship. And finally, we're going to have some shooting and object pooling. And what we're kind of starting to put together here is, an old school asteroid shooter, kind of like the late 1970s Atari Asteroids game. Because what we're doing is normally you don't do a whole lot with, with the vector graphics and drawing and stuff like that, in when you're doing game development. But we could do kind of an old school game with that, and I was thinking that would be, kind of fun. Doing some of that drawing was reminding me of asteroids playing when I was a kid. So anyway, we're going to move forward with some of that. I had, recorded a previous version of this tutorial, and the problem I was having was I wasn't sure how much detail I should go into on some of the trigonometry that's involved in rotating and shooting and stuff like that. So I'm only going to cover it in a real cursory sort of way. And if you have any questions, please feel free to post something to YouTube or just tweet me on at TypeScript Games. Let me know that you got questions. I might make a video in further detail, but I'm just not sure how deep I need to go into the trig, on this. I mean, trigonometry, it's super important for game development, but I don't know to what detail I need to go. So I'm going to leave it pretty cursory in this video, and I'm going to count on you guys to ask me questions if you need to know some more. So the first thing I'm going to do is just tear out a couple classes we don't need. If you remember, this was from the previous tutorial, and it basically just some simple canvas drawing stuff, just drawing a bunch of shapes and things like that to the canvas, which is in black here. And I was moving them one pixel to the right each frame, so they're kind of all shifting to the side. And that was just kind of a tutorial on classes, and interfaces within TypeScript, as well as some basic canvas drawing stuff. So right now I can get rid of this rectangle class. We're not going to use that anymore. I'm going to get rid of this circle class. We also don't need that. So let me just get rid of those. This point class, I'm not going to change it yet, but we're going to change this guy to a vector class because, now that we're getting into more of the I use this initially just to basically track X and Y at the same time. But, we're going to get into some like scalar and vector values where, vector having magnitude and direction. I don't really need this point anymore. What I need is more of a vector. So let's start off by doing the keyboard input. That should be a good place to start. So the first thing we're going to need to do is add a function that is capable of basically grabbing the keyboard input event. So first thing we do is create this function that's taking as its parameter a keyboard event. So when we take this keyboard event, what's coming in this is something called a key code. So whenever you press a key on your keyboard, the system is going to trigger a keyboard event. And this function is going to be basically attached as an event listener to that keyboard event. And then what comes across in that event is something called a key code. And you need to look these up online. So you're going to have to go and Google, whatever key you want to put in. Just Google or Bing JavaScript key code for whatever letter. Like this one here is left. So if you wanted M, you Google JavaScript key code for the letter M. But this key code 37 is for the left arrow. 38 is for the up arrow, 39 is for the right arrow, and 40 is for the down arrow. Now, here I have what it's going to be doing eventually, which is turning the ship left, accelerating, turning it right, and decelerating. But for the basics of getting the keyboard input, we're going to comment these guys out, and we're going to put in like a simple alert to just tell us that it's doing what we think it's doing. And so this one is just going to say left. All right. So let me grab this, put it here, comment you out. Here, comment you out. And put it here, comment you out. Now they all say left, which we don't want. We want each one of these alerts to tell us what it is we're doing. So this one is doing up. This one is doing, the right arrow. And this one is the down arrow. Okay, now this isn't going to do anything yet. And the reason is we never set it up to have this keyboard input function actually listen to anything. So what we need to do is we need to add an event listener to the document for the key down event. We'll start with that. So here's the window on load, and we will add this add event listener, document.add event listener, key down, keyboard input. This is the function we created up there. The other thing I need to do is I just killed all my circles and rectangles, so I need to get rid of this. All right, and also I don't really want those shapes to move constantly to the left or right anymore. They're moving to the right, so I need to get rid of this. So if you remember, this is our game loop. This gets executed every time a frame is run. And the way we do that is using this request animation frame for game loop that basically tells the system, okay, next time you're going to render a frame, call this game loop. So what it's doing here is looping through all our shapes, and it's adding one to the x coordinate, which is going to shift it to the right. So we're just going to get rid of that because we don't really need that anymore. And let's see if this works. Let's see if we get our keyboard input. Okay, so we got our two objects now. And up, when I press up. Right, when I press right. Down, when I press down. And left, when I press left. All right, so that seems to be doing what we wanted it to do. All right, where do we go from here? Okay, so now I think it's time to replace this point with a vector. So let me go grab that code, C vector. All right, so I've created a class called vector, and it's gonna replace the point class because we're not going to use that anymore. So everything has got to switch. Let me walk through what I've added to this vector. So this is where I'm going to really briefly cover some of the trigonometry, because I guess I'll cover as little as I have to. And if you have any questions, please let me know. I could do something more in detail if anybody wants it. If not, then I won't. All right. So we still have our x and y values from, but now we have a magnitude. And magnitude is basically like the length from 0, 0 to whatever this is. And the way you get the magnitude is just the straight up Pythagorean. I mean, this is basically like a squared plus b squared equals c squared, So that's why you have to take the square root. Let me just bring this guy up. So just quickly, you'd use a lot of trigonometry in game development. And if you've done trig in school, you're probably kind of used to the origin doing this is a Cartesian coordinate system. This is why you need trig, because everything has got to have a position, on your screen. And if you've done, a Cartesian coordinate system in school, it's probably had something that looks like this guy right here, which is like an origin in the middle. And if you want to add, basically, if you want to go up, you add positive y. If you want to go to the right, you add positive x. If you want to go to the left, you subtract from x. If you want to go down, you subtract from y. Now, this is kind of the standard Cartesian coordinate system with your origin, which is like 0.00 in the middle, okay? But in games, and also on the HTML canvas, you have an origin that's like up here, up at the top. And the reason for that is back in the day when, the monitors were like CRTs, the monitors would have scan lines, and they'd go, they'd scan this way, and then they'd sweep back, and then they'd scan this way, and they'd sweep back, and they'd scan this way, and they'd sweep back, and they do that all the way down the screen. So, consequently, your pixels are numbered like 1, 2, 3, from left to right, just like you'd expect in any Cartesian coordinate system. But then they numbered the scan lines 1, 2, 3, 4 going down. So consequently, on your HTML canvas, the positive y goes down, and I always get a little messed up by that because I so want everything to work like this. And the positive x, goes to the right. So that's kind of pretty normal and expected. But the positive y going down is a little weird if you remember trig and geometry from middle school and high school. So anyway, what we're going to need to do, the reason we need this stuff is because we want our ship to basically be able to turn and be able to shoot in the direction it's facing. So if you have a game where if you push left, your ship just kind of like moves left, and if you push right, your ship just kind of moves right, then that's not going to really need as much of this the trigonometry stuff, because you're just going to subtract from or add to the x coordinate. But what we have here is kind of like a momentum. So if you remember playing asteroids, when you had your ship facing this way and then you turned, the ship would keep going in this direction until you pushed up, and then it would accelerate in the way it was facing. So when you did kind of a maneuver like this, your ship would end up moving kind of like this along an arc, which was kind of neat. And then you'd have to turn your ship, so you were kind of like sloshing all over the place. But it's because the ship had momentum, and it would keep going. And the way we're going to do that is basically with a velocity vector. The other thing is, the ship, it's not always like, in Space Invaders, no matter what, when you shot the bullet, it always went up. So that's pretty simple. But, in asteroids, the bullet's shot in whatever direction you're facing. So when you want to rotate your ship, when we rotated it before, we're just rotating the way it was drawn. So you do that by just basically rotating the canvas. So, when you have your ship like this, and you want to just rotate the way the ship is drawn, you want to rotate it up, to like that, all you have to do is call ctx.rotate, by whatever angle in radians that you have. And, so when you push the left key, obviously, you're going to want to change your rotation. I think we subtract. No, we add. So if you want to rotate it left, you basically say, you give it a rotation angle. You're like ang angled out here, plus equals some value, 0.2, let's say. And then if you want it to go the other way, you just say angle minus equals 0.2. And that'll basically rotate which way your ship is facing, one way or the other, by just turning the way the ship is displayed. But you also need to know what direction that bullet's going to fire in. So we have to actually take a unit vector that I call orientation, and we're also going to need to rotate that vector around a point. And that's going to start out at x equals 1, y equals 0. And as you rotate it, one way or the other, you actually have to you actually have to like do some math to rotate that guy around one way or the other. So I'm just gonna gloss over that basically, but I'm gonna show you, where that is within the vector stuff, within my vector class. So here I have magnitude squared, which is doing everything that magnitude's doing, except it's not taking the square root. And there are actually a lot of reasons to do, a lot of places you could do this to save yourself some compute cycles, because the square root is actually, taking a square root is actually pretty heavy on the compute cycles. Here's where I normalize the vector to some length. Typically you want it to be some magnitude. Typically you'd want it to be 1, and it's 1 by default here. So basically I'm just getting the length, and I'm dividing the x and y coordinates by the length, and trying to make it whatever length I want to make it by passing in this value. And typically you would just normalize it to a unit vector. So the reason I have this magnitude number equals 1 here is because if you just say normalize and you don't pass in a parameter, it's going to default to 1, which is what you would frequently want. This function is just to zero out the x and y, and copy is just copying the x and y value from another vector over to this one. And this is the rotate that I talked about, which is just doing some basic trigonometry stuff in order to rotate the x and y value around the point. And here's get angle, which is basically just taking the arctangent of your x and y in order to figure out what angle in radians your vector is facing. Here's multiply. Basically, we're just multiplying by a scalar value. We're just multiplying this value times x and y. Adding a vector. So we're just taking another vector and we're adding the x value and the y value, and subtracting is doing the opposite. If you're coming from some language and you don't know what this fat arrow is and this equal sign, like why I'm doing that, the reason I'm doing that is because this is kind of this works weird in JavaScript. It doesn't always do what you want it to do. So this is kind of like TypeScript's way of having this behave properly. So if you're using object-oriented programming, I would always recommend using the fat arrow to define your methods, because otherwise this might not do what you expect it to, this keyword. All right, so that is our new vector class, which replaces the point class. So we're going to have lots of places that we need to change things up. So first of all, we have our asteroid. I'm just going to change these to say C vector and C vector, even though we're going to change this class more significantly later. All right, but the first thing we're going to want to do, let me just do a quick replace. C point with C vector. Let's just replace all of them. Boom. All right. That way we don't have to worry about that. Okay, so right now we're going to keep asteroid the same. We will change that later. But we need to change spaceship because, if you remember up here, we've got all these new spaceship methods that we don't have them defined yet. So I actually have to go and define these guys. We have turn left, turn right, accelerate, decelerate, and those guys aren't anywhere yet. So let's go grab that. Siege. Okay. Grab the new spaceship class, and then we'll walk through what all we have added. Even though we don't have this variable defined yet, we will do that, but got to get there first. Let's go replace this guy. Boom. All right. Okay, so we still have, the old stuff like X, Y, line width, color, size, rotation, and point list. So these were below this line. All this stuff is the old stuff that was in the previous class. But we've added velocity. So this is what we were talking about, that scalar vector, or that vector rather, that tells us how fast we're going and what direction. Orientation is what way are we facing, and we need this orientation because we need to know what direction the bullets are going to shoot. We've got max speed squared and max speed. The reason I've got an underscore here, and this is private, is because I'm actually going to use a getter and setter method for this guy, which we haven't gone over yet. But getter and setter methods are basically ways you can create things that look like variables or attributes on an object with the way you interact with them from the code that are actually calling functions, and they're super convenient. Okay, and here's acceleration, which is how fast we're going to be able to change our speed. We're going to have kind of a separate braking system that's going to be a little different because the game won't have that in the end. We're just using that for convenience sake at the moment. So, all right, let's see where we are. Okay, so we've added this accelerate method, and basically what we're doing here is taking the orientation. Basically, if we haven't moved at all, if we've got like 0 velocity, then we need to take the orientation, multiply that by the acceleration, and copy it into the velocity. So we copy it to the velocity first, then we multiply it by the acceleration. This temp point, and it really should be called temp vector. Let me replace that because we're going to call this temp vec. Replace all. Okay. So this temp vector is basically, we don't want to change the orientation in accelerate because acceleration should not change the orientation. So what we have to do is copy it first to someplace else so that we don't modify it. And then we need to multiply what we had as our orientation, which is now housed somewhere else, by the acceleration scalar value. And then we need to add that vector to our velocity, and this is not right. Right now, this here is saying basically what this is saying is if we've exceeded our maximum speed, then copy over the orientation. That's not what we want. We want to, if the velocity's magnitude squared is faster than our max speed squared, first we want to copy the orientation over, and then we want to multiply this dot temp vec dot multiply by this dot max, our maximum speed. So we actually want to have, or take our orientation, multiply it by the maximum speed. Actually, no, what we want to do is we want to take this is what we want to do. We want to take our velocity, this dot velocity, and we want to normalize that to our maximum speed. And what that'll do is it'll reduce our maximum speed, or it'll reduce our velocity vector to be no larger than our maximum speed. So that's how we should basically cap off how fast we're going. We should never be going faster than whatever the maximum speed is. So I had that wrong in the code. Anyway, so here we have our deceleration, and this is kind of a bit of a kludge here, because all I'm doing is basically reducing the velocity to 90% of what it was when you hit the down arrow until it gets to a certain speed, and then I just cut it off completely. And that's just kind of the decelerate. I don't know that this is actually going to be there in the long run, but I have it there now because I want to be able to slow the ship down, because in the game of asteroids, you can go flying off the side and you wrap around to the other side, and we don't have that in there yet. Like if you go off to one side or the other, there's no wrapping, so you just end up, you end up shooting off into space someplace you can't see it. So it's nice to be able to kind of decelerate quickly, and that's why I have this. I mean, I could just set this to 0, but I don't want you to completely stop at that. Anyway, all right, so these are the getter and setter methods that I talked about. Get, set, max speed. And what this does is, if you wanted to find out what the max speed of this object is outside of the object itself, since underscore max speed is a private variable, you have to use the getter and setter. And when you set the maximum speed, I don't know what just happened there. I jumped way up top. All right, when you set the maximum speed, it actually does more than one thing. It sets this maximum speed value, and then it also sets the maximum speed squared, because we're testing that every time through the loop that you're holding the accelerate button. So it's a lot cheaper, to test against max speed squared than it is to test against max speed, because you don't have to do the square root when you're checking the magnitude of the velocity vector. So, if you remember back to when we were doing vector stuff, hopefully you do. Anyway, so we have all that in the ship now, but we don't actually have a spaceship still. So I need to get a variable for the spaceship, which is here. I'm going to create a few things up top, and we're not going to use them all right away. So here's the spaceship that we needed. I've also got a bullet array and an asteroid array. We don't even have bullets yet. I'm going to need to comment that guy out. And I'll also comment out the asteroid array, because we don't need this just yet. But we do need this spaceship, but we need to create it. So, if we go to the bottom where we create all our objects, we're creating our spaceship object here, and we're just stuffing it directly into the shape array. So instead of doing that, I'm going to create this guy here, or I have this variable declared, but there's no object associated with it. No object's been created. So I'm going to take this new statement, which creates a new object, and I'm going to stuff that new object into this variable spaceship. And this ship is larger than I'd like it to be, so I'm going to shrink him to maybe down to 8. Okay. So, but now I need to stuff him into the shape array. So let me take this and put you into the space array. Or shape array, not space array. The shape array. Okay, so we loop through and we render these guys each time. But now I've added some keyboard input that should take the spaceship and allow you to move it. So let's give that a test, see if it works, or if I messed up somewhere along the way. Okay. Something died. I don't know what though. Oh, but it seems like our ship is accelerating and decelerating and turning the way he's supposed to. Now we don't have any collision detection, so you could just fly right through the asteroids. We're not going to do that in this tutorial. That's going to be for a later time. And I lost my ship. Even though I have the decelerate, still lost my ship. It's so easy to lose him. All right. So, sometime after this, we will get the collision detection in, but we're not going to do that this time. Instead, I'm going to move on to shooting the bullets. So we got to add that guy. So the first thing we need to do is add that bullet class that I was talking about. So let me grab him from my other file, and we'll put him after the vector, right above asteroid. All right, so let's walk through what this guy is. All right, so a couple things. This first one is just a Boolean that says whether the bullet's active or not. And the reason we have that in there is because we're going to be doing what's called object pooling. Now, what I could do is every time I press the space bar, I could create a brand new bullet, and just never delete him. But then we're going to have all these bullets that are taking up memory that, and processing power that aren't actually doing anything. So it would start off just fine. You fire the bullets and fire the bullets. But after a while, after you got, a few thousand bullets, then suddenly everything would start to slow down. You say, well, why is it slowing down? And the reason is because you'd have all these bullet objects that aren't doing anything. So instead, what we do is we keep a list of bullets, and we set the we start them out with an active flag of true. But let's say when they fly off the screen, because once they fly off the screen, we no longer need them. Or when they hit something, eventually they'll hit something and be destroyed. Then we have to say, okay, well, this bullet's done its job, and now it can retire. So we set his active flag to false. But then later, when we want to fire another bullet, rather than always creating a new bullet, the first thing we do is check our bullet lists to see if any of them are inactive. And we'd loop through our list of bullets, and we'd say, okay, are any of these guys not currently doing anything? And if that turned out to be the case, then rather than creating a new one, we just take that bullet that wasn't doing anything and ask him to do something, reuse him that way. So that, if you do game development, you absolutely have to have object pooling. So I figured we might as well start off with that rather than, do something that won't work in the long run. So here's some of the standard stuff: X, Y, line width, size, red. Now, I'm also animating this guy. I thought it would be kind of nice to have like a variable line width, so it would look like he was kind of pulsing. So I'll just show you what that looks like by creating a new bullet and just sticking it sticking it out in space. So we'll say C bullet. We'll make this 150 and 200, and we'll give him a size of 5. So I just made all that stuff up, and we'll just see how that bullet looks. All right, so he's right over here, and he's just this little pulsing square, So I got that animation. The reason I just thought I'd add a little bit of animation to it. Let me walk you through how I'm doing that. So I have this line width animation value. And this value is basically going to go up until it hits a certain point, then it's going to go down. And, the width up is a flag that's telling you whether you're adding to or subtracting from this line width animation value. Then, of course, we also have to have a velocity vector, and this is for movement. These two guys up here, these two variables are strictly for animation. They don't do anything else. Velocity, is like we discussed for the ship. This bullet's got to have a velocity, X and Y value that it's moving. And speed, below that, is how fast this guy is going to be moving. And we only deal with that, when we launch it. So we have a default speed of 5. So the launch, this launch function is basically something that's going to be called whenever we launch a new bullet. And it's basically just going to set the velocity value. That's all this launch does, is set the velocity value. And it does that by grabbing the orientation that you pass into it, which will be the ship's orientation in this case, and then multiplying that times the speed, which we defaulted to 5 up here. Okay, so in the draw, this is where we do the animation stuff. But the first thing we do is we check to see if this guy's active, because we're going to have a bunch of guys that have gone off the screen and been set to inactive. And we don't want to bother drawing them if they're not active. So if active is false, then just return. There's no need to draw this guy. So that width up is just a flag that's either true or false. And basically, if the width up is currently true, we add a little bit to the line with animation value. And if it gets to a certain width, like 2 or more, then we start decreasing the line width. So the line width goes up until it hits a certain value, and then it goes down until it hits another value that's -2. And then it goes back up. So you get that pulsing effect where it just goes up and down. It's super simple animation. Then we have to actually move this guy based on velocity. And then, we check to see if this guy has gone off the screen. So this is a 720p canvas. So it goes 0, 0 in the top corner down to 1280 by 720. So if the bullet has gone a little off the screen, like we don't want it to be destroyed the second it hits the edge of the screen, we want it to go a little bit further, just in case, there's an object that's a little past what you can see. But basically, if the x value is less than -10 or greater than 1290, or the y value is less than -10, or the y value is greater than 720 or 730, then we deactivate this guy, so that he can go back into the pool and that we can use him again. And here's just our standard constructor. Okay, so now we have that object defined. We're not actually shooting anything, right? So let us create this bullet array, which is going to keep track of, what we're shooting. And I am also going to modify our game loop and put some other stuff in. So first thing I'm going to do is get rid of this loop that's drawing all the shapes. Instead, we're going to draw the ship, we're going to draw the bullets, and we're going to draw the asteroids. Oh, I need to declare those variables. So we're doing that in lieu of drawing all the shapes. And I got to get rid of that shape array because he's just going to cause trouble. So let's get rid of that shape array. And let me go right back up here. So here's what we're doing. We're taking that spaceship we created and we're drawing it, Then we're looping through all of our bullets and drawing those. Then we're looping through all our asteroids and we're drawing those. Okay, so what I now need to do is go down here and I got to get rid of this ship array or shape array, and I need to change that to asteroid. And I also need to get rid of those guys because we're just going to have the one asteroid for right now. I'm going to start out trying to create bullets, but now we need a way to actually create bullets. So we've got this. We're setting our asteroid in here. We don't need to put the spaceship into one of these arrays that renders because we're calling the draw class, or we're calling the draw method directly on that guy. See, spaceship.draw. So we're going to draw the spaceship, then we're going to draw each bullet, then we're going to draw the asteroid. Now we've already put one asteroid in here, but we've got no bullets. So if I run this, we've gotten rid of our bullet. We don't have our bullet there anymore. So we've got the one ship and we've got the one ship, one asteroid, and that's it. So now I need to figure out how to add those bullets. And we want to do that using the space bar. So that means we need to add something to this keyboard input event. Something that is going to shoot those bullets whenever we press the space bar. So let me go grab that code. Okay, so key code 32 for the space bar. And we have this bullet, but we haven't created a new bullet yet, right? So this is just creating a variable that doesn't have like a new bullet. The new object, the object is not created. This just creates a variable and we haven't set it to anything. We will do that later. Like if we were doing something, just creating a new one each time, we'd have this say equals new C bullet, and then we pass in the parameters, and that would be that. But we don't want this because this allocates memory. This new, when you use the new keyword on an object, that is allocating memory, and we don't want to do that because, as I said, you could fire a lot of bullets, and if you don't get rid of them, they just stick around, and they have to be garbage collected eventually. So your garbage collector will basically, I don't know how often it runs. It seems kind of random to me, but you might have, when you don't have like good object pooling, when I wrote some of my early games, you'd have a game and it would like stutter because you could tell whenever the garbage collector was running, it would go and it would be fine, and then it would suddenly you would just pause for like almost a second, in between two frames, and then it would kind of jump. Like, oh, that's weird. And that would happen more and more frequently until it was just unbearable. So anyway, we're not allocating any memory to this bullet. It's, by itself. So the first thing we're doing is we're looping over the bullet array that already exists. And we're looking to see if we've got a bullet that's not active. Because if it's not active, that meant it went off the screen or something like that. Maybe later we'd have it, actually destroy an asteroid and become inactive. But it's no longer in use. It's no longer being rendered or anything like that. So we're not using this one. And if we find one that we're not using, we're just going to break. And break means we're going to bust out of this loop, meaning that this guy that got assigned here must have been inactive. So then down here, we're checking if that's true. So is the bullet we found active, meaning that it just went all the way through and each one was active no matter what, or the bullet null, meaning that there were no bullets in this array. So if there were never any bullets in this array, the bullet would be null. If there were bullets in the array, but every single one was active, then this would be true. And if that's the case, then we have to create a new bullet. We have to allocate that memory. So if we found no bullets that are inactive, then we've got to create a new bullet, and then we push it into the bullet array. Otherwise, we just need to take that bullet, set its position to the spaceship's position, and set it basically his x and y values, and then we have to make him active again by setting active to true. And then after either of those, doesn't matter which one we do, then we could go ahead and launch the bullet. So let's see if this thing worked. All right, so turning. Oh, look. Oh, see. If I just hold the key down, then it's firing like a stream of them. So obviously, I need to add some delay to how often those bullets fire. Otherwise, I could just hold that button down, which kind of a cool effect. But that's not what we want. See, there's a ton of bullets there. So we can keep firing these guys without having it slow down because it's just reusing the ones that already exist. Now we only have one asteroid, so why don't we go back and just create a bunch of asteroids? Because it would be nice to have, obviously, when we have the game, we're going to want to have, more than one asteroid just sitting there. So let's just add a bunch of these guys and run it. Now, here's the problem. All of these guys look exactly the same, and they're all spinning at exactly the same rate, and that is kind of lame. So we're going to go and we're going to change the asteroid so that there's a little more variation there. So it's not always the same, because this would look pretty terrible. So let me go grab my asteroid code and bring it over. All right, so stop this guy. Where's my asteroid? Paste him in. And we'll talk about what we did here. All right, so now we have asteroids of different shapes, and they're all kind of moving, with different rotations. And if I refresh, then they change. They're not the same every time. I hit the refresh button and they're different. So It's pretty simple. We just use some random values to make these asteroids all a little bit different. Let me show you how that's done. So before, all we were doing was going through this list of points and just drawing them, you know. So the first thing we do is we set the rotation speed basically equal to some random value. Before we had it set to some value. Now this is all in the constructor, by the way, for the asteroid. So this is what's called when the asteroid is created. So the asteroid gets created and it's getting assigned this rotation speed. Now math.random returns a value between 0 and 1. So we don't want it to be a value between 0 and 1. We want it to be a value between 0.03 and negative 0.03. Well, how do we do that? Well, the first thing we do is, if you ignore this part here, the first thing we could do is have it set between 0 and 0.06 by multiplying this value, this random value, by 0.06. And the way that works is this. So let's say, let's say this is on the low end and it's 0. 0 times 0 is 0, so you get a value of 0. Let's say it's on the high end, 1. 1 times 0.06 is 0.06. So that works out. So any number you multiply this times random ends up being some random value between 0 and whatever this is. So that's okay, but that would mean they would all spin in the same direction. Even though they'd all spin at different rates, they're all spinning in the same direction. Well, we don't want that. We want half of them to be spinning in the other direction. Well, how do we do that? Okay, well, we could subtract half of this value, like we did before, and the way that works is this. So let's say this is on the low end. This value is on the low end, and the value you get is 0. Okay, 0 times 0.06 is 0, so all this is 0. And then subtracting 0.03 gives you negative 0.03. Oh, okay, so now we have a minimum value of negative 0.03. Well, what about on the high end? Okay, so 1 times 0.06 is 0.06. 0.06 minus 0.03 is 0.03. So that basically changes it from being, between 0 and this value to being between negative this value and positive this value. And, I do that later with basically each individual point. So I want to also tweak where the points are. So I created this xrand and yrand value, and I basically took a random value, multiplied it by the size, and subtracted size minus 2. And so that basically allows me to shift every point in my asteroid by some pixel, depending on how big I've made my asteroid. So anyway, this is just an easy way to use random numbers. And I'm going to be posting this code to my website, TypeScriptGames.com. And if anybody has any questions, if they want me, to do more detail on something, or if they want to tell me I'm doing too much detail on something, please let me know. You can just tweet me at TypeScript Games, or you could post something on YouTube. Just let me know what you're thinking. Let me know how I'm doing, and please subscribe to my channel if you get a chance. Thank you very much.